Hi everyone. So today our topic of discussion is the monocular cues. They're also called the psychological cues. Essentially, cues are nothing but indicators. So monocular cues of depth perception, they are very effective when we view the objects just with one eye. And they are usually used by the artists. Why? Because they need to induce depth in their two-dimensional paintings, and more so they are also called the pictorial cues. And when we talk about monocular cues, what's amazing is that they actually help us judge the distance and depth in the two-dimensional surfaces. So many a times we've also observed that how if we could be standing at one end of the road and the road is surrounded by a lot of trees and it's a very long road, we literally feel that the road actually is converging or it's coming close, especially towards the other end of it. So this is what happens in monocular cues. Now we have some of the most amazing and interesting types of monocular cues. So to begin with, we have the first one, which is the relative height, and it says that the larger objects are always perceived as being closer to the viewer and the smaller ones are always perceived as being farther away, literally. So the larger of the two will always appear to be closer to us, and the smaller one will always appear to be farther away, isn't it? Coming to the aerial perspective, very important. So the air actually, if we come to see, it contains some microscopic particles of dust. So these dust particles along with moisture, they actually make the far off, or so to say the distant objects, look very blurred, look very hazy, very unclear basically. So what happens is, whenever we could actually be traveling to mountain tops, or if we could be going to a hill station, many a times it happens with us that we look at mountains from a far off place, from literally a far flung area, and we feel that they are actually blue in color. We literally see them very hazy, very blurred, something bluish. So this is what happens, that this is nothing but this is the phenomena of aerial perspective. This effect is called aerial perspective. Why? Because these distant mountains, they appear blue because of the scattering of blue light in the atmosphere. So literally when the blue light scatters in the atmosphere, it gives it that blue tinge, which literally isn't true, because when we reach there, we don't find them blue. We don't find them hazy, blurred. So in fact, we find them much more clearer, because that's what happens. But from a far off place, from a distant area, we see them very blurred, very hazy, very bluey in color. But on reaching, there's nothing like that actually. So this is what is called the aerial perspective. So when, of course, we have the next one, which talks about the light and shade, and it says that in the light, there are some parts of the object which do get highlighted, and some parts they become very dark. And of course, when we go there, when we reach there, we are not able to see anything like that. But again, this is but a monocular cue, like how in the aerial perspective, we were feeling like that. But of course, on reaching closer to the mountains, we don't see them as blue, hazy, or blurred. Similarly, light and shade is also a monocular cue only, because these highlights and shadows, they are providing us with information about an object's distance. That's it, literally. So this is also a phenomena, right? So moving on, we have the next one, which talks about uh, the monocular cues, which is the linear perspective, which says that especially how the distant objects will always appear to be closer together than the nearer objects. So we have observed this especially in the rail tracks, that when we actually see these rail tracks with an increasing distance, or we literally try to peep out of the window and we try and see what's happening on the other end of it, so we see these rail tracks coming close or converging. But when we reach that point, there is nothing like that happening. So this is once again a monocular cue, right? And this is what is happening even in light and shade and aerial perspective. So upon reaching, we don't really witness anything like that happening, but we do feel this is how we perceive things, isn't it? So we will see them converging on the other end, because we are looking at them with an increasing distance. So with that increasing distance, we will see them converging, but literally that is not happening. So the rail tracks are not literally converging. So then, of course, moving on to the next one, we do have the next types, and the next one talks about the monocular cues, which is the relative size. So it all depends on the size of the retinal image which is being formed on my retina. So that is going to determine whether the object is larger or smaller. So even if we have two objects which are exactly same, exactly similar, when we view these two objects, the farther one will always appear to be smaller, and the one that's closer will always appear to be bigger. That's because uh, you know um, we tend to perceive an object farther away, and we also feel that it's smaller because it's quite far away. So with the distance also, it tends to become smaller, the retinal image on my retina, and the closer one will always appear to be big, because the image that's being formed on the retina is comparatively bigger. So the size of the retinal image will allow us to actually judge the distance, and it's all based on our past and present experiences pertaining to the similar objects. So even if they're similar, that does not matter. But here, of course, it is the size of the image being formed on the retina, which in a way depends on the distance very clearly. So moving on to the next type, we have some more types, and we do have the interposition, or also called the overlapping, which clearly says that the portion of the object that's going to be covered by another object, that of course object that is being overlapped by another one will always appear to be farther away, and the one that is overlapping will appear to be closer to us. So here the red triangle is being overlapped by the green one, so the red will appear to be farther away, and the green one is overlapping, so it'll appear to be closer to us. And this is something which we've also witnessed, we felt, but literally when we go close to it, we feel there's hardly any distance. But when we look at it at a distance, we feel that, okay, that's appearing to be smaller, and the one that's covering it appears to be larger. Even if they could be of the same size, height, but upon reaching, we find out that there is hardly, barely any distance, and it's just about the portion that's getting covered, or it's being overlapped. So again, it's about interposition, it's about overlapping. So the next one, of course, we have the texture gradient, very important. So this actually is quite interesting, because if for instance we take example of maybe a floor or a wall that is bricked, closely bricked, and if we could be standing on the floor, and at one end of the floor, we'll actually feel that the other end of the floor is quite densely packed. Maybe that the number of bricks used on the other side of the floor are comparatively more, because they appear to be densely packed, closely packed. But that's not the case. Essentially, the same number of bricks could have been used. They could be used, on the entire floor. But because I'm looking at it with the distance, so with the increasing distance, I'll feel, there's greater density on the other side, because there's an increasing distance, so to say. And when we talk about even the bricked wall, we'll feel exactly the same way. So this phenomena, basically, we come to see, it says that the visual field that has more density of elements will always be seen farther away. So literally, with the distance, it'll appear to be more, the density of elements will appear to be more. And you can even try this out at home. If you have a bricked wall, you could try and stand at one end of the wall and see the other end of it, and you will actually feel that the elements on the other end, on the extreme end, the density of elements is greater. But that's not really the case. So this is again a monocular cue. Coming to the last one, which is of course motion parallax, which clearly says that, if we could be moving in any bus, train, when we could be moving literally or traveling, so the closer objects, they actually appear to move in a direction opposite to us, and the farther away objects appear to move in the direction like just as us, the same direction. So if we just see this picture, we see there are some plants literally that are closer to the window comparatively, and in the moving bus we would see them moving against our direction. So if this lady is moving towards, our left, so the planters are moving towards the right. And if we see the sun that's quite far away, so this object will appear to actually move in the same direction as us. So that is something we've always felt. We've always realized this kind of feeling when we could actually be traveling in cars or buses or trains. Many a times we enjoy these kind of perspectives also. So these are some natural phenomena that have happened time and again with us and happens every day with us. But to name it, of course, these are monocular cues or the psychological cues. And they are actually helping us judge, the depth, the distance. So this was all about the monocular cues. Thank you so much.